Next up, we have Ramin Keene.
Great. Thank you very much. All right, so production as an experiment lab. This is actually a great speaking slot because you're warmed up for the day and you've had your coffee, but you haven't quite eaten lunch yet, so you're very suggestible when your blood sugar is low. And I want to be absolutely honest that this talk is meant to be a subtle and gentle assault on your better judgment as people who operate production systems. So what are we talking about here? We're going to cover a lot of information in this talk, and I will, at various points, take entire fields of academic study and boil them down to one slide, and you're just going to have to roll with me on this. But as a quick introduction of what we're going to cover, these are most of the concepts. So we're talking about complexity, systems thinking, socio-technical systems, and complex system failure. But the real gist and point I want you to walk away from this talk with is this idea. Production experimentation. This idea is totally ridiculous. We should absolutely be doing that. And that's my hope. So just before we go any further, I want to give you a quick introduction to who I am. Software engineer. I spent a lot of my career as the software engineer on teams of data scientists. So if you remember around 2011-12, when it was declared that data was the new oil, lots of companies over-indexed on bringing people in from academia to be data scientists. And after a couple of years, they realized, well, none of this software or anything that these people are building is actually going to get into production. And they found unassuming software engineers like me who wanted to roll with the PhDs and had us join the teams to help get all this stuff into production. And if you know, there's the adage they say that if you're sitting around a poker table and you're not sure who's there to lose all their money, it's you. I say that if you're sitting on a team and everyone around you is really diverse and intelligent and has a PhD and you're sitting there with them, they've got you there because you're going to carry the pager and put things into production. I mean, we've learned more about this now. We understand data engineering and machine learning engineering, and it's not quite the case. But just as a warning, if you find yourself in one of these teams, that's what's happening. They're going to make you run everything in production. A bit more about me. I've spent the last year building a suite of adversarial experimentation tools that help you orchestrate and perform valid systems experiments. But really, most of my success has been in making really dope memes. I see a giant camera pointed at me, so I'd just like to point out that the one of these that is a clear trademark infringement had nothing to do with me. I just put it there as an example of a really good meme that is like one I would have made. So let's begin with this. Like, why am I even beginning to talk about experimentation? So let's just very quickly blast through some of these concepts. So systems complexity, I will go deeper into these. I just want to cover it here. But why I think we should start to think about experimentation in production software systems. So we've got this concept of complexity, and complex systems exhibit high levels of emergent behavior, which themselves are unknowable and unknown. And a key part of systems are the humans that are participants in running and operating these systems. And the reason the humans are important is because we are constantly learning about these systems. So I warned you earlier that I was going to take entire fields and boil them down to very simple slides. So here's the answer to everything. All software and operation of software comes down to these two things: complexity and change. You've got the answer there. Yeah, when you go back to work, then you say, how was DevOpsDays? Like, yeah, there's some guy got on stage and figured everything out. So let's talk about these two things, complexity and change. Complexity is essentially this idea: how does this thing even work? And how did it ever even work? And then change is this: I'm about to break this. So let's get into complexity. And I actually saw someone walking around yesterday with a T-shirt that said, simplicity is genius. And I kind of wanted to go slap him in the face, to be honest with you. Because I mean, yeah, that's maybe a bit mean. But there is this impulse that we have to think that any level of complexity is something to be avoided. And the actual truth is the opposite. You know, complexity is a side effect of business success. And what I mean by that is, it is essentially that complexity is unavoidable. So when I talk about complexity, what I mean is, it could be that you have like some legacy system that you built early on and you've iterated on your business, and therefore you have complexity in the number of systems you have to manage. But what's really interesting is there's complexity in terms of your org structure and the number of people you have. So if you are a successful business and you have lots of people, you suddenly have a giant coordination and change problem, and you have necessary complexity in how you organize people and manage change. So I just want to go a bit deeper on complexity here. There's two types of complexity: essential and accidental. So when we're talking about the thing like the guy's T-shirt yesterday, that's accidental complexity. This is what happens when you don't quite understand the problem and you have created a solution, and what happens there is you create a solution that is accidentally complex, such that you can iteratively improve it and make it simpler, or at least improve it. I don't want to get stuck in this complex-simple dichotomy, but you can improve it and steer it more towards essential complexity. So when I talk about essential complexity, this is the complexity I'm getting at, and I want you to really grasp with me today. I'm talking about this kind of thing, which is the Amazon and Netflix kind of complexity. Has anyone seen these two pictures before? Yeah. So the one on the left is Amazon's microservices architecture, I think some point around 2004. And this is what we're talking about, complexity. They have thousands of engineers, and they've created a deliberate process for how they organize their teams, such that there is inherent complexity in how they've organized their software systems. There's a very interesting law called Conway's Law. Has anyone heard of this? Yeah, so the idea behind Conway's Law is that your software systems will necessarily reflect the communication structure of your human teams, which essentially means you're going to ship your org structure. And this is what we're talking about with this kind of complexity. So yeah, trying to convince you to accept complexity, this is really the takeaway I want you to take from it, is that the solution to complexity is not simplicity, sorry t-shirt guy, but what it really is that we have to learn that complexity is something to be accommodated, embraced, and managed. And like the reason I bring up this complexity is primarily as a way of leading you to this secondary idea about complex socio-technical systems, which is that complexity and failure go hand in hand. I'm going to speed ahead a bit, but we're talking about complex systems failure. So again, as I said, I'm going to take about 25 years of academic research into resilience and socio-technical systems and boil it down to this one slide, but it'll be good enough for now. And it's such that failure in complex systems is continuous. So all complex systems are necessarily hazardous, and even the layered defenses we build into those complex systems themselves become the hazards. So the safety mechanisms and things you might put into the systems themselves become the source of catastrophe. And a catastrophic outage in a complex system comes from multiple components in the system failing. The failures that we experience in these systems are always novel, meaning you can't reason about them and learn about them before they've happened. And really, the main point is these last 2 points, which is error detection is very hard, and error prediction is basically impossible. John Osborne has a post he's written about dark debts, which is a bit like dark matter. And the idea behind that is, in complex systems where there's high degree of interaction between the components, there are very unknowable types of failure that cannot be reasoned about in advance, a bit like dark matter in the universe. And it's kind of antithetical to us as engineers who want to be able to just understand things in order to be able to fix them. But that's really what we're talking about here. So yeah, tying it all together, we've gotten to this point where we've accepted that complexity is a necessary side effect of success. Complex systems exhibit this state, which I'm talking about here, which is everything is always a little bit broken in a way that we weren't expecting. And really, the reason I want to get to this point is to have you think about humans. So there's 2 points here about complex systems, and this is really boiled down, and the previous slide, from Richard Cook, who's a resilience engineering academic, and he has a great website. It was like how.complex systems failed, and yeah, there's a great deal of research on complex systems. But really, these are the 2 main points. There's no root cause, and I know this has become a bit of a like rallying cry in the DevOps community, but the point I want to make is that yes, it's probably really great for the business when something goes wrong and you create a root cause analysis and the business likes that, and yes, this will never, ever, ever happen again, and everyone's happy about that. But yeah, think about it this way, and this isn't my quote, so don't attribute it to me, but you know, the root cause of every plane crash is gravity existing. Great, we solved it, awesome. But really what's interesting here, and what I think is most interesting from the complex system research, is that you as operators of production systems operate in 2 roles, and this isn't something I brought down, but it relates very much to my previous joke about complexity and change. And the 2 roles are such this: at some point, you're a creator of the system in that you're a participant in changing how it is, but during an incident, you are a defender of the system, and the point of that is you are now learning new properties of the system. Does that make sense? So the point I want to get to is this, and I touched on it earlier, is that humans are participants in these complex systems. And the reason I bring this up isn't just to say that you're wonderful, because most businesses would love to get rid of you, sorry to break it to you. But really what it means is that the most important part of you as humans as part of these systems is it's about learning. This is all leading up to experimentation, trust me. So let's revisit change in this context, which, yeah, specifically in the context of measurement. So I said earlier that all software is 2 things, complexity and change was, I'm about to break this. But given what I've just said about complex systems exhibiting all this unknowable behavior that we can't think about, how can we even begin to think about reliably changing a system such that we can be confident about how it's going to behave? We can't, right? So here's an adage I want to get to, and this should hopefully get you to the idea of thinking about how we think about change and experimentation with infrastructure systems. And I'm sorry to throw this big, giant wall of text at you, but I'll try and read it out like it's coming naturally out of my mouth. We wouldn't change a button in an app without 10 meetings and a 6-week A/B test, but Eddie from Ops can change the entire performance profile of the business with a config change, and no one bats an eyelid. So let's just think about that for a second. Just changing the color of a button will have tons of meetings and people worried about it, but your infrastructure engineers, namely us, can completely change how the business performs. And I'm not just talking about the metrics and the monitoring of, is the system working? Like, we can completely change the profile of the business and the core business KPIs, and no one even knows we're doing it. Maybe it's an instance change, a config change, changing whether we're using a cache. So there. So yeah, getting onto that, given what I've just said about complex systems, experimentation, and managing change, and reliably changing things in a way that we can know about being unreliable, that's my thesis for why we should start to think about experimentation in terms of infrastructure systems. And it's really this point. We want to control the changes, think about exploration and understanding of unknown properties of the system behavior, and measure how those changes have had an effect on the business. And it's really this point, control. And we'll revisit this later when I start talking about field experiments. So hopefully at this point, I've lured you into a way of thinking where you're like, yeah, experimentation, we should do that. But we're kind of up in the ivory tower still, right? This is pretty high concept, we're in outer space. So what I want to do next is kind of bring it back down to earth and talk about things that we do know about. And I like to think of this in terms of establishing a vocabulary for how we think about system and infrastructure experimentation. So there's 3 concepts that are relatively new in the production engineering and SRE field. But I think if you tie them together and position them in relation to one another, they provide a really nice vocabulary for thinking how production experimentation is actually very achievable today, and that we can actually adopt this. So these are the 3 concepts: test in prod, progressive delivery, and error budgets. Has anyone heard of any of these? Everyone. We should have. So, all right, who's heard of test in prod? All right. So until about a year and a half ago, test in prod meant this guy. Like, stay on call, my friends. But this is what it meant. It meant you were the cowboy. You didn't really test anything. You just threw it into prod. But over the last year and a half, the concept of test in prod has completely changed. And it's largely driven by someone called Charity Majors, who's really pushed this idea and got us all thinking this way. And what it actually means, well, what test in prod actually means is, it doesn't mean release without testing. What we're actually talking about here, and I've heard shift left mentioned a few times. I like to call this almost like embracing right, which is what we're talking about with test in prod is extending the software development lifecycle beyond release of the software. So what this means is, traditionally we've always thought of you build your production artifact, you deploy it, and that's it. It's in production, you don't touch anything. And what we're talking about test in prod is, let's get into production and consider that part of how we're testing and operating the software. And I think this is really the case with test in prod, and this is the big, like, mind-blowing aha, is that we're all doing it. You know, you deploy, you're testing in prod, whether it happens, we just pretend that we're not really doing it. And this is the other thing, you know, we've all had the excuse from a developer team saying, it works on my machine. But really, whenever, you know, talking about staging environments, I would posit this. Staging is just, it works on our machine, like the shared local machine, and we should be pretty aggressive about considering staging what it really is, which is just this. It's like a shared machine, but it's not production at all. And so who, probably in the last few months, has had a developer team come to them and complain about how accurate staging was? I see a bunch there. Right, so this is my thesis, and it's not just mine, but everyone. Like, spending more developer cycles and infrastructure cycles on trying to make staging more better is absolutely wasted effort. And there's absolutely diminishing returns. Because again, if we think back to what I was saying about systems complexity and emergent behavior, and this is a quote from Charity Majors, Mipsy Tipsy, what's really interesting is being able to observe the change of your software in production. And it's the real users, real traffic, real scale that allow you to explore the real unpredictabilities and really begin to reason about your software. So that's test in prod. And then really the point of bringing that up as the first part of the vocabulary for thinking about experimentation is really what I said earlier about not shift left, but embrace right and start to think about production is part of our SDLC, the life cycle. Let's embrace it and start to think of tooling and not be so precious about production. I've really covered that. But yeah, really the gist is it's gone from being a developer joke to something that's actually a really common practice. So the second concept I want to get into is progressive delivery. Has everyone heard about this? OK, so this was a term coined by James Governor from RedMonk. And this is his quote for it. It's progressive delivery is continuous delivery with fine-grained control over the blast radius. So most people actually reject this idea and say, isn't this just CD? But really the point is, and if you remember earlier I said about control being the word, progressive delivery is much more interesting because it's about separating deploy from release. Like, traditionally we've just deployed and that's it, the code is out there. But what progressive delivery is getting at is deploy the code, but don't release it to the users and have fine-grained control over how you're controlling the release to individual segments. So there's like a limited set of tools that make up progressive delivery, but they're pretty broad. So feature flags, A/B testing, and canary deploys. We had Harness up here just now as a sponsor. You know, they're taking care of that canary side of things. But that's really the gist of it. Separate deploy from release. So you know, an interesting point about progressive delivery is that it's much more attractive to the business and the enterprise, because the concept of continuous delivery is actually completely scary to them, because what they imagine is that developers are just changing things and it's all going out and no one has any control. But when you start to talk to them about progressive delivery, it's like very attractive actually. But this is the gist. Let's start thinking about fine-grained control of how we release software to individual segments of our users and measure how that is affecting them. And that you can see how we're now shifting from we just deploy the thing and we think it still works to let's actually think about this in terms of business KPIs and changing things for individual users and see if things line up there. But the big thing that I think is important about progressive delivery is this. It kind of embodies a mindset shift from correctness to safety. And this gets back to what I was saying about the complex systems. And particularly the T-shirt guy. I'm sorry, I keep ragging on the T-shirt guy, but you know, there's this impulse to think like if we just make it simpler and better, it can be right and correct, and we'll spend more cycles on better staging environments and more correctness. But really, if you let that go, embrace this idea that everything is always broken, and undertake this mindset shift from correctness to safety, it's actually incredibly liberating. And once you have these tool sets, it gives you a way of thinking about production experimentation, such that if you let go of correctness and just focus on safety, which is what progressive delivery gives you, that's your tool set for thinking about rollback, gradual release, and it's super great. So if we've accepted that managing and observing production is part of the life cycle, and separating deploy from release is a safety mechanism and a method of control, we've got a couple of things there that are really powerful. So my original idea of production experimentation seemed ridiculous, but is it hitting? Are you starting to realize, like, hey, we actually have tools for this right now. This is actually what we're doing. And now if you think back to when I was the patsy on the team of data scientists, this is starting to look like what they used to talk to me about when they exposed me to proper science and the scientific method, which is this looks like field experiments. This is what, you know, people I worked with who used to work in biology or the field would talk about in terms of getting out there and doing things. So now what? I said there was like 3 parts to this vocabulary, and this is the last one I want to touch on, and it's actually my favorite because this is like a real mental shift to go through, and it's error budgets. So we've all heard about error budgets as a way of sort of controlling prioritization of reliability versus feature work, and particularly with psychological safety for us as like infrastructure engineers in terms of alert fatigue and whether we do need to jump on and actually fix something. You know, is this within our error budget? Do I really need to wake up and fix this? But there's another way to think about error budgets. And I'll get to it shortly. But again, as I said, I'll take entire things and boil them down to one slide. So there's really only 2 threats to your availability. Is that the software changes or its environment changes. And I want to get back into this in that the environment changes means you haven't actually changed the software, but something has changed such that it is now more broken than it was before. So things like network latency, resource contention, these are all things that you can traditionally explore with fault injection. So what I want to get at with error budgets, so I said that it was a way of prioritization, but what I really want to get at is that error budgets should actually be thought of as a giant opportunity. So think about it this way. If if you are greatly exceeding your error budget, you're actually doing a disservice to your client. And when I say a client, it could be another team inside your organization that is relying on you with your particular SLI or SLO. So what you should be thinking about is if, hey, I like to say it this way, if the natural distribution of failure has for some reason completely spared you, you might have some nines to play with. And what you should actually be thinking about is those extra nines that you may have accidentally been blessed with are a great opportunity for you to proactively explore learning about the unknown behavior of your system. This is a really subtle idea, and I don't think it will necessarily hit right away, but it's this idea that you can have made your software too reliable. Yeah, but yeah, if you accidentally have increased reliability, you should be proactively trying to use that as an opportunity to explore how it is broken. So yeah, this is my statement. It's not your job to create infinitely reliable software. This is very similar to the, yeah, it goes hand in hand with the idea of like, yeah, you can't actually make it simpler too. So I imagine, yeah, some of you will go back to work on Friday and your boss will say, how was DevOps Days? You can say, yeah, this guy got on stage with tattoos and a weird voice. He said, yeah, we should leave the software extra broken and they'll never let you come back here again. But send them my way if, but yeah, this is the gist of it. Like, we have an impulse as engineers to make everything absolutely perfect, correctness, simple, completely working, and it's just not actually realistic. So this is the point of the last part of the vocabulary for thinking about experimentation. Error budgets are your opportunity where you should be doing experimentation. So let's think about what some types of availability experiments might be. Performance, cost, capacity, new architectures. So that's what I establish as a vocabulary for thinking about production experimentation. So we've gone from this very lofty idea of academic thought about socio-technical systems, outlined a few ideas here from SRE and production engineering that are very current and things we're thinking about now. And now I want to just confess that the nature of this talk was a giant lie. I completely lied. So I said production is a lab, and now we're going to get into a bit more details about why experimentation is not testing. But lab is not the field. So a lab is necessarily a controlled environment. If you imagine doing science, imagine, you know, Darwin goes to the Galapagos Islands. He didn't come back to his lab and try and recreate the Galapagos Islands. He actually did his experiments there in the field. So the whole concept of my talk that got me accepted was a total lie, because you can't create production as a lab, but it's a field experiment. So what is a field experiment? This is the shift you have to make. You shift from controlling the environment to thinking about excludability and non-interference. So you can see how this really relates back to the progressive delivery idea, such that you're trying to really control the release of the software to be about excludability and who is being exposed to this new feature. So yeah, if we think about that again, lab is about controlling the environment, looks like staging. Field is controlling exposure, production. We're starting to get something that starts to work here, right? This is starting to seem quite normal. So we have staging, lab, test, concepts that all go together, and we've got production, the field, experimentation. And I certainly think, hey, here's a concept that works, right? Production, field, experiments. So I'm going to just skip ahead because I know I'm running out of time, but this is the other thing. Probably all of you, or some of you, are looking at me like, well, what's the difference between an experiment and a test? Isn't that absolutely the same thing? Touching on what we said at the beginning about complex systems and continually learning as humans in the system, I would posit that this is the difference between a test and an experiment. A test is about verifying and confirming behavior that you already believe to be true about your system. This is what staging, unit tests, CI/CD is about. This is a property of the system I already know. I want to verify that it's still the case with the current change I'm at. An experiment is about creating new knowledge about the system or invalidating some assumptions you believe to be true about the system but you haven't been able to explore yet. And this is where I think the leap is, where we go off here. Okay, we're starting to think about production. We're starting to build tools that let us operate the life cycle in production. This is experimentation. And this is the gist of it. Experiments lead to new knowledge, tests don't. So we've got a complex system. There's lots of behavior that is highly complex and highly emergent, and we need to experiment to learn about it. So this is pretty simple, right? But experiments aren't just about changing stuff. Orchestrating valid experiments is incredibly difficult. And really, the point of this is that constructing and orchestrating an experiment is about generating valid data about changes that you can be highly confident about. And this is very difficult. So before I go any further, has anyone heard about experimentation in infrastructure already? Can anyone think of anything that people are already talking about with this? No? Chaos, yeah, exactly. So I would posit, and this might be a bit controversial, that how most people are talking about chaos experimentation is experimentation in the sense of how I might experiment with a funny type of hat versus a true field experiment. Like I said, experiments aren't just changing stuff. It's really, really hard to generate valid data. So a lot of case experimentation is very focused on the scientific method in terms of forming a hypothesis and invalidating it. But a lot of the tooling around performing these experiments are actually pretty immature in terms of what you might find out in the scientific field. So I like to bring up this quote by a statistician called Ronald Fisher. It says, to call in a statistician after the experiment is done may be no more than asking him to perform a post-mortem examination. He may be able to say what the experiment died of. So again, I'm going to boil down 100 years of academic research, but this is all the stuff that's really difficult about performing good experiments. Validity is what it's going to. Does this even test what I think it's testing? Bias. Have I constructed this experiment in such a way that I'm just hoping to confirm what my assumptions were about the system or what I want the outcome to be? There's this concept called the Hawthorne effect, and you can read many papers about each of these. This is like a really broad field. This could have been the whole conference about just this slide alone, so sorry to bombard you. But there's the concept of self-fulfilling prophecy. And the things that I find most interesting are continuation. Like I said, once you're learning new information and new properties about the system, you're going to have follow-on experiments and new questions you want to ask, especially when you're experimenting with infrastructure. And that's really where it starts to get difficult. If you've created a segment, exposed them to some change, and then you want to do a follow-on experiment, how are you making sure that you're still working with that segment of users? It's really difficult. And if you're just like injecting faults and doing chaos engineering, I don't know if that's going to work. So let's get a little bit into specifics here, because I've been kind of out in outer space, dragging you around there. But how can we think about this with systems? We're operators of systems. Like, let's get specific. So my solution is this. Let's think about a request and how it moves through your system as a foundation to orchestrate experiments and measure them. And we have a tool set of ways to think about this for control and measurement. And it's routing. Routing users to different parts of your infrastructure. Distributed tracing as a way of good enough modeling of system behavior. Your SLI and your SLO as a way of measuring whether things are within acceptable bounds. Safety mechanism for, is this experiment fucking shit up really bad? And then really thinking about your business KPIs for the exposed segment. And this is really the gist of this. And this is what I was talking about with the infrastructure engineer who can completely ruin the business with a config change. Let's start to think about how we're changing infrastructure such that it boils all the way back to the goals of the business. So I'm going to get into some specifics. Again, acknowledging the camera, I'm going to anonymize this. Like, if there was no camera here, I'll tell you what these companies were. But I'm going to go first and say how to do a really wrong experiment. So one place I was helping with, it was a two-sided marketplace. It was a bit like Uber, but not for cars. And they were A/B testing the search scores. So their solution to how to construct this experiment was to do switching based on the user segment that they had chosen and put flags on in the database. And what they would do is, for those users, they would double index the data. And then if someone had conducted a search and they were in the segment based on database lookup, they would expose them to the different index with a different ranking algorithm. And what actually happened here was this was a completely invalid experiment, because what they'd actually introduced was a performance penalty to people who were inside the group because they had twice as much data. So naturally, the new index performed poorly, but what you were actually measuring there wasn't the quality of the ranking algorithm. It was actually a performance regression because there was double data. The real correct way to have done this would have been to, like I said before, route the users to a different set of infrastructure and expose them that way, and try and really control the actual performance and make sure that was apples to apples other than this switching thing. So I want to get into a couple of scenarios that I'm going to skip this one. I'm going to get into this one, which is I think is a really interesting idea. So working at an e-commerce place, there was like very dynamic pricing data that we would expose to users. And it was actually very cost prohibitive to try and get this to near real time. There's a big company, so I don't want to mention them because I don't want lawyers. But the idea here was, are we spending too much money on developer time and infrastructure, making sure this data is real time? Where could we introduce a performance penalty of 200 milliseconds, save a few $1 million a year, and not affect the business too much? So the way we did this was to route at the edge layer, deterministically parameterize users into particular buckets. And this is a really important way to think about creating segments, because what it means is you can reconstruct the experiment data after the fact, because you're deterministically creating these segments. And what we do at that point is route them to a completely different set of infrastructure with the penalty and be able to run that experiment for a longer period of time. I'm talking like 2 to 3 months, and completely measure the effect of those users on add to cart and checkout flow. And what we found is that, yeah, we saved $2 to $3 million a year on infrastructure costs, loads of time and heartache and toil on trying to make this near real time, and it actually didn't affect the revenue of the business. So this is what I'm talking about with experimentation. So the last idea I want to introduce around experimentation is this concept of the multi-arm bandit. So if you think about a normal A/B test, you can construct your control and your variant group, but there's this quite advanced concept of the multi-arm bandit, which comes from the references to like the slot machines where you pull the arm. But what this does is a self-optimizing A/B test. So what it'll do, it'll explore a range of the experiment space and some degree of parameters and try to self-optimize for an outcome. And something we've seen in the wild that people are starting to experiment with is actually running these backwards, if that makes sense. So what you do is, instead of trying to optimize for the highest positive case, is you actually optimize for a worst case. And this is like a new advance in the chaos engineering that I semi-skewered earlier about those not being proper experiments, which is trying to inject many small faults and explore the failure space in like a micro failure way, and explore where the edges of safety are in your system that way. And this is something we're seeing out there in the wild, which is very advanced experimentation that people are starting to do. So it's happening and it's out there. You've got to believe me on this. So yeah, I just want to summarize here. I think the way we're thinking about production and operating production is just begging for us to be talking about field experimentation and bringing this knowledge and these lessons from real scientists and thinking about how we operate infrastructure that way versus us just changing shit and hoping it's all for the best. I think that, this idea of embracing right and forgetting about left and right and really thinking about production as a living part of the complex system and building tooling around that is where we need to be going. And I think, I think operating in production is like a completely unexplored part of software and systems operation. I always like to think of it as all of software so far, we've just discovered Europe, and then thinking about test in prod and experimenting in prod is like, Columbus is about to set sail for the Americas, and we haven't even discovered production yet, and all the wonderful things we can do to increase reliability and create a new field of thinking about production out there. I just want to revisit this one idea, because I think this really hits home, which is this idea that, the business and how we think about changing the color of a button is something that would be highly sensitive topic. But us as DevOps and infrastructure engineers, we can change the entire performance profile of a business, and no one even bats an eyelid because they don't even know we're doing it. And why is that? I think our time is going to be up pretty soon on this stuff. Thank you. That's it. I'll post these slides later, and there's lots of further reading of all the academic stuff. I boiled down to like one slide, and you can dig into it if you're interested. But yeah, thanks. That's it.
That was awesome. Thank you. Any questions? Where will the slides be posted? We'll find a way to get them to all of you.
I'll post them to my GitHub, and it's just my first name, GitHub Ramin.
I have a question. What's the first step to adopting this kind of practice in production?
Yeah, I think it's really for us, these people here, to start thinking about what our role is in the business. It's kind of always looked at as the kind of infrastructure team is just an enabler to get things done and get it over the line at the very end of the process. So earlier on in my career, I was a music composer, and I did a couple of films, and it was a very similar case where you would be given the final cut of the movie to then score or like do the sound on with a day to spare. And it's kind of kind of similar with infrastructure. You're sort of given the artifacts very late. So I think being in the room and starting to think about, yeah, this isn't just about getting it built and pushing it to production and forgetting about it. It's, you know, think about production as like a living, breathing, complex system that's constantly changing. We have to give it its respect that it's going to fuck with you. You know, it's always going to be broken, and and think about safety. So.
Whose production system is constantly changing?
What was that? I didn't hear you.
Whose production system is constantly changing?
Yeah.
You're the ones that know that it is.
I mean, they're always changing, but they're always in a state of being semi-broken, and it's fine.
Exactly.
It's fine.
Yeah. Awesome. All right. Another round of applause, please.